Our research represents one of the first systematic reviews of robotics and artificial intelligence for asset lifecycle management in the offshore wind sector. We provide a critical review of the most recent advances in industry and academia. As part of our analysis, we propose a roadmap for the future integration of robotics and AI in the offshore wind sector, providing supporting evidence for the barriers that we need to overcome.
We also discuss the interdependent factors that will inform rates of adoption within academia and industry by providing an evaluation of investment, regulation, and skills development, creating a pathway to advancing the sector.
Given the need to decarbonise quickly, but not at the expense of the environment as per the concerns of the UN Decade of Ocean Resilience, we need to think creatively and responsibly.
Offshore wind is experiencing unprecedented growth. This is expected to scale to 30 gigawatt by 2030 in the UK and will require critical infrastructure and a large number of subsea cables, which was estimated to have reached 2.5 million kilometres in 2020.
Offshore renewable energy represents a rapidly developing sector, which will ensure a future carbon-free, resilient energy network.
Some key points in the offshore wind energy sector include the following. Floating wind is rapidly developing, however, is not yet widely available for all offshore wind farms.
And the pace of developments in turbine design have resulted in increasing both the number of new wind farms being commissioned and the distance from the shore that these larger capacity turbines are situated.
Priorities in offshore wind relate to operation and maintenance costs, reducing the duration of inspection, and increasing safety. The offshore sector also faces similar pressures as other industries with respect to the circular economy and sustainability challenges.
Currently, 85 to 95% of wind turbines are recyclable. However, due to the durability of the blades, these are typically burnt or sent to landfill, presenting difficulties in sustainable disposal.
Current offshore deployments are heavily reliant on people and logistics. Key challenges include weather-dependent deployment, expensive logistics and equipment, long durations of inspection, and risk in hazardous offshore environments. Methods of deployment include helicopters, heavy lift vessels, crew transfer vessels, and subsea divers, all of which are expensive and produce harmful carbon emissions. Therefore, questions exist in how sustainable the offshore renewable energy sector actually is. Our roadmap ensures a prosperous and sustainable future in the full life cycle of the offshore renewable energy sector.
In addressing these capability gaps, there will be more opportunities in the full life cycle for robotics to help. We utilize a hype curve to highlight levels of visibility and autonomy with respect to time. This evidences the rate of visibility for robot type and each segment of the exposure of the robot within design, development, and deployment, represented from the innovation trigger to a plateau of productivity.
We also identify that robots are being used for short-term functions and single-use cases, which limits the deployment of robots for O&M. The direction of travel, as we see it, is to ensure robots can improve beyond the plateau of productivity, which includes multi-robot fleets that are free from human intervention for significant periods of time.
This requires a hyper-enabled operational overview via a digital twin which supports beyond visual line of sight missions and bidirectional communications to ensure real-time updates.
Deployed robotic and autonomous systems represent a means of automated symbiotic interaction between both robotic and human elements in the offshore operations and maintenance model, improving efficiency and safety, while also reducing costs and saving time.
These technologies can play a vital role in supporting the entire life cycle and circular economy of an offshore wind farm, which includes surveying, planning, design, logistics, operational support, training, and decommissioning.
This review identifies the need for resilience, self-certification, ontology, trust, and digital twins.
In our roadmap, differing types of inspection robots acting in unison will be resident to their operations area, maximising mission efficiency.
This reduces time for inspection compared to current human-led inspection routines. Resident robotics also benefit situations where robots are deployed to offshore areas to perform inspection tasks, saving time and money on planned and unplanned deployments and maintenance missions.
A cyber-physical systems approach is creating human partnerships with autonomous assistants, where extended reality technologies can be used to view the status of the robot or mission updates.
We identify autonomy as a service as a key requirement for the myriad of sectors in advancing the regular deployment of autonomous assistants as tools for personnel.
Multi-robot fleets will play a vital role in the creation of autonomous assistants. Of equal importance is how these autonomous systems connect across each other and to humans, infrastructure, and environment. Bidirectional communications to a digital twin will ensure an enhanced operational overview is achieved so operators can verify safe deployment, reliability, and resilience of robotics.
Our future work includes the investigation of resilience by creating an offshore analogue for a multi-robot fleet via an asset integrity inspection for corrosion and subsurface wind turbine blade defects in the Field Robotics Laboratory at Heriot-Watt University. Our industrial guests will be able to stress test the resilience of the inspection by selecting mission variables on the day which will disrupt the mission. The multi-robot fleet will have the capability to adapt, survive, and thrive through these external disruptions, which can be found in dangerous, stochastic environments. This has been both an academic and industrial study. For other relevant research publications, see the links currently displayed, where we encourage outreach for any collaborations towards resilience via the following channels.